So this first one we're going to have a look at, we're looking at solving geometric problems. When I talk about geometric, I'm talking about like shapes and things to do with diagrams and drawings. If I ever say like, oh, what's the geometric meaning of this? I want you to think, what does it mean if you were to draw it, okay? And actually this kind of geometric problem, I've put this in because this is actually a GCSE question, but we know what happened with GCSEs this year, so this is probably a question you haven't had much exposure to, okay? But you're going to be fine with this because it's building on all the things that we've done so far. So it says here, I've got this picture of this parallelogram that has been drawn. In fact, it hasn't told me it's a parallelogram, but I'm telling you it's a parallelogram. It really should have mentioned somewhere that this is a parallelogram because that has the interesting properties of the opposite sides being the same length and parallel, which for vectors is going to be rather important. So the diagram's got a lot of information on it, but we're still going to read what it comes up underneath. And it says that x is a point on AB such that AX to XB is equal to 3 to 1. M is the midpoint of BC. Show that XM is parallel to OC. Now, when there's a lot of information in a question, I like to just deal with a few bits to begin with, add some stuff to my diagram, and then be like, okay, cool, I've dealt with that bit of the information. I'm now going to move on to the next part. So first of all, I want to deal with this thing where it says that XM to XB is 3 to 1. So what does that mean? This line that I've got between AX and then XB, what fraction of the whole line is A to X? 3/4. Okay, so to go from A to X is 3/4, and to go from X to B is therefore going to be 1/4. It doesn't mean that the length of that line is 3/4. I'm just using my diagram to say that this is 3/4 of the whole length, okay? It doesn't mean it has a length 3/4 because I haven't been told anything about the lengths yet. I'm just using it as a proportional measurement that I've got. And then it also tells me that M is the midpoint of BC. Well, that just means it's halfway, obviously. I'm not going to ask anyone about that. It just means it's going to be halfway. And then it asks, it says, show that XM is parallel to OC. So I'm going to just draw these on, and I'm going to draw them on with a different coloured line for a second. So X to M is parallel to OC. Now, do they look parallel? Kind of. I know. I don't think this is exactly in the right place. It's not in the right place because they should be parallel. That's what we're trying to show, that they are parallel. I think the diagram hasn't been perfectly put that this is 3/4 and 1/4. Now, when it says show that question, that doesn't mean that you can use the fact that they are parallel and then be like, you can't use the end goal. The end goal is these lines are parallel. That's what we want our last sentence to be. So we can't have that as our first sentence. We can't assume that they are parallel. In fact, we have to just assume they're not parallel and then show that they are. Okay? So when it's never a show that question or a prove question, you can't use the thing that you're trying to show or that you're trying to prove because it kind of undermines itself, if that makes sense. Okay, how do we usually show that XM and OC are parallel? Think back to a couple of lessons, Jamil.
The gradient is equal to the same.
So the gradient is equal, but we're doing vectors here, so we don't really talk about gradients very much. Khadija? They are multiples of each other. Could you try and write that for me as like a mathematical statement? So I could say like XM equals something like that. What constant do you want to name? K, okay? XM equals K, OC. If I can show this, if XM equals KOC, where K is a constant, then XM and OC are parallel. And the thing that is, if you have finished writing that, the thing I think that's going to be cool about this question is that it would work for any parallelogram at all, with any lengths and with any angles, as long as it's a parallelogram and you had the same sides labelled in the same way, if you split this diagonal into the ratio 3:1, and you did this midpoint here, this and this would always be parallel to each other, no matter what the parallelogram. And that's why we're trying to use vectors to generalize something. Rather than just doing it with a parallelogram, vectors allows us to do it with all parallelograms. And mathematicians get interested in being able to prove things for lots of general cases, okay? And we'll get there with that. We'll enjoy doing that as well, even though I've said these are going to be tricky. Okay, good. So in order to do this, I need to work out these two things. I need to find out what xm is, and I need to find out what OC is. Then I'm going to compare them and see if I can find out what k is equal to. So which of those ones looks like it's going to be easier to find out? OC. So let's do OC. So I'm going to start off by saying what OC is equal to. Ismail, what is OC equal to?
Oh, it's B plus A.
B plus A. It is B plus A, or A plus B. It's the same thing, okay? So OC is going to be equal to A plus B. The harder one is obviously going to be what xm is going to be equal to. So I'm just going to first of all decide what pathway I want to take to do xm. Minhaj, how am I going to go from x to m? You tell me which pathway you want to use.
Back to A.
This one?
Yeah.
You want me to go back to A,
And to O.
and then to O,
B.
and then to B,
And then to
and then to M. I think that's a long way. I think if I'm going to go from here to here, you taking me here, 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 I wouldn't want you to be like a driver for me or something, like taking me all around the houses. Come on, there must be a quicker way you can...
No, so if you're a taxi driver and you have the thing running for
Oh, you're trying to get the meter running for longer. Okay, right. This time we're imagining you need to get to hospital like really quickly. Like what's going to be a more efficient way to get the person into the hospital on time? Like which way are we going to go? There's got to be a better way than going the way Minhaj said. Even though it would still work, by the way, Minhaj, it still would work. What do you say, Sufyan? We're starting at x. X to,
B.
I think x to b,
Oh.
and then b to m.
Oh, I didn't see that.
Okay, I also wouldn't want you driving me anywhere either. Okay? Lily, were you going to say the same route? Yeah, I think either this route is the best. I mean, I really think that route is the best. It's going to be the most efficient in terms of the calculations. So I'm going to write down that we're going to go, for x to m, we're going to go from x to b, and then from b to m. And notice how we've got those same letters here. The second letter is b, and the first letter is b, because obviously we're leaving b, and then we're arriving at b, and we're leaving b. So what is xb equal to in terms of ab? It's a quarter of this long line, which is AB. So it's a quarter of AB. And then BM is a half of BC. BM is a half of BC. So it looks like I should probably do a couple of bits of side working then, and I should actually work out what AB and what BC are. So what is AB equal to?
A plus B.
Yeah, or B minus A. Same thing, okay? B minus A, because these are the position vectors of A and the position vectors of B, and it matches up with what we were saying before as well. And then the other one we want for B to C is just going to be A, okay? B to C is just A. So I'm now going to come back to this, and I'm going to start doing some of the calculations. So I'm going to say it's a quarter of AB, which is B minus A, plus a half of BC, which is just A. So I get a quarter B when I expand the brackets minus a quarter A plus a half A. So what's minus a quarter A plus a half A?
It's 1/2. Yeah.
No, a half minus a quarter is a quarter. So I have a quarter A plus a quarter B. So I've now achieved the two things that I wanted to find. I wanted to find out what OC was, which is here. And I wanted to find out what XM was, which is here. So do you see how when Khadija gave me this first sentence, that actually gave me the instructions of what to do. It told me I need to find this and I need to find this. So I'm going to find it, I'm going to find it, and then I'm going to come back to that sentence that Khadija told me, and I'm going to try and see if that's true. So we have that XM is this, is equal to K times by OC, and OC is AB. So what do you think K is equal to just by, so K is a quarter, so K equals a quarter, hence XM equals a quarter OC, so XM and OC are parallel. So if you've finished writing that down, don't tell me immediately. I just want you to think to yourself, what more can you tell me now that we've finished that calculation? We found out that they're parallel, but I'm sure there's more that we know about these. Don't tell me yet, just have a think. Just what does all these calculations, what do they actually tell us? They tell us more than the fact that they are just parallel. They tell us something else that the question hasn't asked for, but we know is true. That's a boring thing, to say they're not perpendicular. We've just shown they're parallel, of course. Has anyone got any suggestions of what you think we could also tell us about these two vectors that we've got here? They are parallel, and there's something else I know about these two vectors. Any suggestions? Andrew?
OC is 4 times the size of XM.
Yeah, OC, the modulus of OC is 4 times larger than the modulus of XM, the length of these things. So if I go back to the diagram for a second, this line here is 4 times the length of this line that I've got here. Yeah. Yes, modulus and magnitude is the same thing. I should be saying magnitude. It's because I'm teaching modulus to year 13 at the moment, so I'm forgetting what you guys know and what you don't know. But it's the same word, modulus, magnitude. It just means the size of something. Good question. Or instead of writing it in the way that Andrew said, that OC is 4 times the size of, 4 times larger than XM, I could have said that the length of XM is a quarter of the length of OC. And I think that's kind of clear to see that the length of XM is a quarter of the length of OC. So it's telling us something additional. It didn't say what is the ratio of these two sides, but we could have said that the ratio of their lengths, if we were going to say the ratio of OC to XM, we could have said that it would be 4 to 1. Why am I putting a 3 in there? The ratio of these is 4 to 1. If they said, what's the ratio of those lengths? You can do that extra bit there as well, okay? So this is technically a kind of GCSE style, but we know the top end of GCSE blends into part of AS level. And we're also going to now look at something that is definitely not in GCSE because it just has like a little extra bit that goes on top of this as well. So we're going to have a look at the next example, and then you're going to try one, but we'll go through it as well because these are some of the ones that people do tend to find a bit trickier. So just make sure you're concentrating as hard as you can for this bit. Can I go on to the next bit? Okay. So this time we're going to introduce some scalars into our problems, and I'll let you know when we're doing this bit. And we're going to do something called comparing coefficients. The coefficient is like the number that goes in front of a variable, okay? So I've said if you had an identity that looked like this, if I said that ax squared plus 3x equals 2x squared plus bx, we could do something called comparing coefficients to just be able to find out what some of these values are. So I could say that a must be equal to 2 because it's the coefficient of the x squared term. They must be equal to each other if this is an identity, okay? And I could say that b must be equal to 3 because those parts need to be equal to each other. And we can do the same here with non-parallel vectors, that if I had something like 3a plus b equals ka plus cb, I could say, well, k must be equal to 3 and c must be equal to 1. So now you'll see why I actually do need to underline things, because if I have these and they're not underlined, you know that they are a scalar, and if they are underlined, then they are a vector, which is why you need to be in the habit of always underlining things. So we are going to have a look at this problem that we've got here. And we've got another parallelogram. It says OACB is a parallelogram where OA is A and OB is B, just the position vectors of A and B. And it says that the diagonals OC and AB intersect at a point X. And there's a very important word here. Prove that the diagonals bisect each other. I said there's an important word. There's actually two important words. I want to start off talking about this word prove that we have here. Now, when you look at that diagram, you probably could have told me back when you first started exploring shapes, so at a very, very young age, you could just be like, well, yeah, it does. Look, it's in the middle. Like, obviously, the diagonals are going to bisect each other. I can clearly see they are crossing at the middle. But that's not what the word prove means. The word prove means if you could imagine any kind of parallelogram that was possibly going to be drawn, would that always happen? And our brains go, well, yeah, of course it would always happen. But that's not how maths works. We need to make sure that we can convince ourselves using mathematical logic that that would always be true. So that's what prove means, okay? We're going to not assume that they do cross at the middle. We're going to try and show that that is the case, okay? And bisect is really what we just sort of spoke about over here. I said that bisect means that they are going to cross each other exactly into two equal pieces. So bisect means to cut equally in half. You know when you just like perpendicular bisector, angle bisector, and things like that, cutting exactly in half. Now the thing that's strange here is that we cannot do, like in the previous question, I cannot say that this is a half and this is a half. Why can I not say that? Because it doesn't say that. It doesn't say that x is the midpoint. We're trying to show that x is the midpoint. We're trying to prove that. So I can't use that information because that's like a backward logic. That's like using the answer to try and prove the answer. It doesn't really make any sense. So I can't put this half and half here instead. I can't put that there. What I'm going to have to do is I'm going to have to introduce a scalar to this problem. And the scalars that I'm going to use are lambda and mu. Do you remember what lambda looks like? It's this one. It looks like I think of that as like an upside down y. And mu is the one that looks like a u with like a little tail at the beginning. So we're going to be introducing some scalars into this problem, okay? And I've said as my hint, and this is going to be the hint for all of these kinds of questions, is find the thing you're interested in, where is x. We're going to try and find x in OX in two different ways. We're trying to go from here to here in two ways. Well, one of the ways I can go to this, one of the ways I can find OX is just going to be simple as just going from O to X, okay? That's going to be one of the routes. What's another route that I could find what OX is? Yep, what do you say? All the way around? How do you mean all the way around?
A plus B plus OX.
So I could do this plus this, but it wouldn't be plus OX, it would be plus CX. There's probably a slightly shorter journey that I could take that wouldn't go all the way around. I could either go to B and then here, or I could go to A and then here. Now, the reason I'm going to take this journey in two different ways is because I want to do something to do with this diagonal and something to do with this diagonal, and I want to show that it's halfway along those diagonals that they meet each other. So we're going to try and calculate this in two different ways. We are going to try and calculate OX in two different ways. One of the ways we're going to calculate OX is by going some distance along the line OC. And this is where I'm going to introduce lambda as the thing that is saying some distance along the line OC. Now, what do we think the value of lambda is actually going to be when we get to the end of the question? We think it's going to be a half, but I can't call it a half because we don't know that. We're trying to prove it. So in this question, we think that lambda is going to be somewhere between 0 and 1 because it's somewhere along that line. We know it's going to be a half, but we are saying at the moment it is a scalar. It is something that is going to be some fraction of that line OX, of that line OC. So that means that OX is going to be lambda multiplied by OC. Well, what is the vector OC? Pardon? Louder? A plus B. It's just A plus B for this bit. So that is just going to be lambda A plus B. And I'm going to stop at that point because I've done enough to calculate what OX is equal to. Are there any questions at this stage? No? If there are things like why are we doing this, it might make a bit more sense when we've done the next part, which I'm going to do in red so that it matches this part of the journey. So we're going to go OA, and then we're going to do AX. Equally, you could have done OB and then BX if you wanted to. As long as you're using the other diagonal to get there, it's going to work out for us. So I'm now going to try and work out what OX is, but I'm going to do this in red to match the fact that I'm doing a different journey. So it is going to be from O to A plus AX. So it is going to be from O to A plus AX. And I'm going to keep working on this. Now we know that OA is just A. And what could we say that AX is?
Lambda
So I'm not going to use lambda because I've already used lambda. I'm going to have to use a different one. I'm going to say it is mu AB. And this time, I'm going to say that mu is in between 0 and 1. We know that mu is going to be a half, right? Because that's what we're trying to prove.
So how come that one's a mu though? Just another constant?
It's just a different constant. Because if I use the same constant, I kind of get a bit stuck because they might not be the same. They might not be the same. If in a different scenario, we might be trying to prove that this is a third of the way along and the other one is 2/3 of the way along. So we can't give them the same constant, okay? So we also better find out what AB is equal to. I'm just going to do that somewhere else on the page. What is AB equal to in this diagram? Minus A plus B, or B minus A, okay? Because these are both position vectors, so it makes sense we have it like this. So I'm just going to go back over here, and I'm going to say that it is A from before plus mu lots of B minus A. I'm going to expand the brackets. So that's A plus mu B minus mu A. Everyone's concentrating really well here. It's good. And I'm going to do something now. I'm going to do a little bit of factorizing so that I just have one A term and one B term. So I'm going to just do an extra line in here. I'm going to do the A minus mu A. I'm just going to put them right next door to each other so it might be a bit easier to see what's happening. I'm going to factorize this. What would this factorize to if I took A brackets 1 minus mu plus mu B? That is what OX is equal to. But I also know that OX is equal to something else. I also know that OX is equal to this thing that I've got at the top. So what I'm now going to do is I'm going to use this hint. I'm going to find OX in two different ways. I found it here, and I found it here. So what do I know about that blue thing and that red thing? They are the same, and the same in maths means equals. Okay, so what I'm going to do now in black, I'm going to say that this OX is equal to this OX. I'm going to say that those two things are equal to each other. So that means that lambda A plus B is equal to A 1 minus mu plus B, plus mu B.
Do we know it's equal because they're both OX?
Yeah, because we're talking about the same vector here. This vector and this vector, they have to be equal to each other, otherwise maths is broken. Okay, we've just described this pathway. That blue vector must be the same as these two red vectors added together. So let's just expand this left side. So we have lambda A plus lambda B equals A 1 minus mu plus mu B. And this is where we will go back to the idea of the second thing in this title. What does the second thing say? We said introducing scalars and comparing coefficients. So I am now going to compare the A coefficient, and then I'm going to compare the B coefficient, and they must be the same as each other. So the A coefficient on the left-hand side is lambda, and the A coefficient on the right-hand side is 1 minus mu. So what do we know about lambda and 1 minus mu? They must be the same as each other. So lambda must be equal to 1 minus mu. Otherwise, they couldn't be the same vector. Then the other thing that I know from the B vector is that lambda and mu must be equal to each other because they have to be the same. They are the same coefficient of the same vector, which tells me that I also know that lambda must be equal to mu. We're nearly there now, okay? You've done really well with this so far to keep concentrating. What next? Pardon? Substitute. Yeah, solve the simultaneous equations. So I know that lambda is equal to mu, so I can replace this lambda with a mu. So I get mu equals 1 minus mu. So 2 mu equals 1. So mu is equal to a half. And because lambda and mu are the same as each other, then lambda is also equal to a half. Hence, the diagonals bisect each other. Because we've said they end up at the same spot. And in order to end up at that same spot, this had to be a half of OC, meaning it was bisected. And this logic had to be a half of AB. So because we wanted to prove that both of the diagonals were bisected, that is why I had to do this blue one using one of the diagonals and the red one using the other one of the diagonals. Okay, I couldn't find the other way of doing OX. If I did OB plus BC plus CX for the red one, I would have only ever used this diagonal that I had here, and I would never have even got this other diagonal involved in the game. So that's why I had to make sure that the pathway incorporated the two diagonals that I was interested in. Ikram?
No.
Are you sure?
Yeah.
Any question, even if you think it's a silly question? What kind of things?
How much marks would that be in the exam?
This is probably the kind of questions that isn't a lot of marks. It's probably like 6 marks. But the reason they have questions like this that are not necessarily a lot of marks is to stretch out the top end. That there might be people, this might be towards the end of the exam paper, and you might not remember how to go all the way to the end of this, but you definitely would know to write out a couple of these statements at the beginning and get some of the marks. So sometimes a hard question doesn't have a lot of marks. A hard question is there to kind of sort out the difference between people getting Bs and A stars and things like that as well. Yeah?
What's the highest marks you can get in A as in for a question?
Broken down across a whole question, maybe like 15 marks.
For one question?
Yeah, one question by itself, I think the biggest I've seen is 10 marks just for like, do the thing.
No way.
Okay? So I don't know, this might be more than 6. So I'm going to leave this one on the board, but what I'd like us to work on is this question. Okay? In fact, I might give us a couple of hints for this one. So this one is a little bit different. Let's just read through this, and then in a second we'll do it together. Not in a second, in a few minutes when you've had a proper amount of time on it. We've been told that OA is A, OB is B, same thing as before, it's a parallelogram, and OQ is a third A. So I know that this bit here is a third A, meaning that this bit must be 2/3 A, okay? We wish to find the ratio OX to XC. They've given us a bit more information. The previous one we had to kind of come up with it ourselves. So they are trying to do the same thing as before of finding out what OX is in two different ways. But they've asked you to say that OX is some multiple of OC. We don't know what the ratio is going to be. And they've also said that BX is some fraction or some fraction of BQ that you have here. So even though it's been broken down into part A, part B, and part C, part A and B of the question is asking you to do an expression for OX in one journey, like this. And part B of the question is asking for you to do an expression of OX in a different journey. What do you think that different journey is going to be?
BX.
It's going to be to do with BX, but it's not just going to be from here to here, because it needs to be OX. So what do I need to add on to that one to make that journey complete for it to go from O to X? It can't just be this yellow bit, can it? It has to be this journey, okay? So what you're going to do for part A of the question is you're just going to say, you're going to calculate what is this green bit. For part B of the question, you're going to calculate what is that yellow bit. And then for part C of the question, you're going to make part A and B equal to each other and see what happens. And then we'll do this question together in a second.